is I will write this as, see, I will write this as q squared y squared is equal to, I will retain it as it is, and see, there are very many ways of doing this, but I will do it in one particular way that you will that is a new type of doing is linear. What I mean is that this can be done in two or three different forms. I will teach you by one method here. Okay. Now, here as I told you, we have to take some transformation. So let us take let capital X be equal to log X, capital Y be equal to log Y. So this will imply dou X by dou X is equal to 1 by X, dou Y by dou Y is equal to 1 by Y. Now, see, we will call this as our 1. Now, our P is equal to dou Z by dou X, which is equal to dou Z by dou capital X into dou X by dou capital X. See, this dou Z by dou X, I will call it as P, and dou X by X, see, dou X by X is 1 by X. This simply implies capital P is equal to P into X. See, we have got this. Similarly, Q is equal to dou Z by dou Y, which is equal to dou Z by dou capital Y into dou capital Y by this, that is equal to Q into, it is 1 by Y, which implies Q is equal to QY, with Q is equal to dou Z by dou capital Y, and here P is equal to dou Z by dou capital X. So we are able to transform the variables to, that is P and Q, to new variables, as capital P is now dou Z by dou capital X and Q is equal to dou Z by dou Y, taking X is equal to log X and Y is equal to log Y. Now we will use this, see, substituting in 1. So call this as 2. Substitute 2 and 3 in 1. So this will give you what? In this place it will be your Q square is equal to Z into Z minus P. So this implies it is Q squared is equal to Z squared minus PZ, which implies PZ plus Q squared is equal to Z squared. Now I am able to bring it to a form. See, if I can bring it to this form, I can identify it in some other. That is, I can give the immediate solution. So what I will do is, for this, we can solve this by the method that I am going to teach you. See, having come to this, I will call this as my 4. Now what I will do is, now I will take like this, let Z be equal to a function U. Let Z be equal to a function Z of U, where your U is equal to X plus AY. Because you see that the Z is now a function of X and Y, not small x and small y, but it is a function of capital X and capital Y. I am taking this U as this. Now I will write here, see what I will write here is, see what is our P? P is dou Z by dou capital X which is nothing but dou z by dou u into dou u by dou x. So, but this dou z by dou u, you retain it as it is, into what is your dou u by dou x? Dou u by dou x is equal to your 1. So this is nothing but your dou z by, so this is dou dz by du into 1. And your q is equal to dou z by dou u, which is nothing but your dou z by dou u into dou u by dou y, capital Y. So this is equal to, so, and dou u by dou capital C, dou capital X is equal to A. Dou u by dou X is 1. Dou u by dou Y is equal to A. So what is it you will get here? So this is A into dz by du. Because I am taking this z as a function of u only. That is why I write it as dz by du, and I got this. So these two results are very, very important. Now what I will do is, now see 4 becomes, what will be 4 now? So in the place of p, you can write this as dz by du into this z plus, what is your q squared? It is a squared into dz by du whole square is equal to z squared. See, substituting 5 and 6 in. So I will substitute this 5 and 6 in 4. So this you must know that after coming to this, I am taking a different method of doing it. I will take z as a function of only u. That is why I write it as dz by du. But when you take this p is nothing but dou z by dou x, which can be written as dou z by dou u into dou u by dou x. But dou u by dou x is equal to 1 because you have to differentiate with respect to x, capital X. So this will be 1. Therefore, dz by du I write because it is a function of u. Likewise, if you find q, dou z by dou y, which can be written as dou z by dou u into dou u by dou x. But this is dou z by dz by du, and the differentiation of this I have given it is a into this. Substitute these two values in 4, you get down to this. Now you see that this is a quadratic equation. Now this simply, see what does this imply? This implies that a squared into dz by du whole square plus z into dz by du minus z squared is equal to 0. So this is a quadratic equation in, so this is what I will write. See, this you call it as sum 7. So this is your quadratic equation in dz by du. So this simply implies dz by du is equal to minus b plus or minus b squared minus 4ac divided by 2a squared. So this is nothing but minus z plus or minus, it is z into square root of 1 plus 4a squared divided by 2a squared. So this is what we get. So this is nothing but, see, so that is equal to this one, because k is equal to, see here I will write it here, It is simply k into u. dz by dz is equal to k into integral of du, where k is equal to minus 1 plus or minus 4 square a square plus 1 divided by 3 square. So here you must know that this dz by du is equal to z into k, where k value is this, and that is dz by du is equal to minus z plus or minus, see, plus or minus 1 plus z into this divided by 2a square. Say I have written here, say this is the value of k. So what is that you get here? Now dz by d is equal to simply k into du. This is also known. So this is also known. This is also known. So it is simply ku plus b. Log z equal to k into x plus ay plus b. That is log z is equal to k into log x plus a log y plus b. Now I will write the answer. See what is that you will get here. I will write it here. So log z is equal to, it is k log x plus a log y plus a constant b. That is log z is equal to, what is in the place of k? It is minus 1 plus or minus 1 plus 4a squared divided by 2a squared into log x plus a log y plus a constant b. So this is our answer. So this k is nothing but this value. By mistake I wrote it as minus. It is not minus, it is plus k only. So you see that this is now the solution for the problem, because we are able to get the what is the meaning of solving a partial differential equation? Finding the value of z in terms of x and y. So I am able to get it in this way. You can find that here there are two constants coming. So you take, this is our complete solution. This is our complete solution. Take b is equal to f of a. Take b is equal to f of a. I will call this as some 1. Take b is equal to f of a. Take differentiation of 1 with respect to a and solve the equations for a. Solve the equations for a, which this gives the general solution. So I repeat this. So having come up to this is our solution to the problem. The old variables have been brought to the new variables have been brought to the old variables. This is our answer, and this is our complete solution. Now here you see that we can take this b, we can express this b as a function of x. Then if you want to find the value of, if you want to get the general solution, you will differentiate this with respect to a, then this will be 0, and you will get some differentiation of this with respect to a. Then solving the resulting equation which is obtained by differentiating with respect to a and 1, you see that you will be able to get the general solution. To get the to get the singular solution, differentiate 1 with respect to b. So if you are going to differentiate this with respect to b, this will be 0, this will be 0, and you will get differentiation of b with respect to 1 is equal to 0. This is absurd. Therefore, no singular solution. for, see, our original problem is nothing but what? For the given problem. So you see that this is the solution to our original problem, and the general solution can be obtained in the way I have taught you just now, and I have given you the explanation how this singular solution does not exist.